Well, hello everybody. Welcome to today's discussion about developing secure applications for IBM. This is going to be a kind of rapid fire crash course in security designed specifically for people that are either programming or administering an IBM system. So we're going to introduce some object level security concepts, maybe clarify some things that you've heard but weren't entirely sure how they worked. This is a great opportunity for you to ask questions of somebody that has been a developer for many years in my past and now focus almost exclusively on security. So hopefully that'll give a unique context here. So the agenda is pretty straightforward. We're going to just do a very quick introduction so you know who it is that's speaking and why I feel that I'm qualified to do so in this particular case. We're going to talk about something that programmers don't really like to talk about too often, and that's the concept of documentation in application design. We're going to talk about some concepts that are very important to understand, and this is really kind of where the crux of the discussion is going to come in, and that's about ownership of applications and the authority that we use in order to secure those applications. We're going to introduce a simple security model. What I mean by that is I'm going to take all of the concepts that I've introduced during the previous section, and I'm going to walk through the creation of an application conceptually. If this were an application I were building, these are the kind of steps and considerations that I would follow in order to do that. Now, I've said it's a simple security model, predominantly because obviously there's different ways to do the same thing under IBM. I'm not saying that this is the only methodology, but it's one that I think is very beneficial, and it introduces several different concepts that I think you can leverage in different ways. Now, most likely under part 2, we're going to finish that up. We're going to also talk about some integrity considerations of the platform in general. Not necessarily completely programmer-centric, but some things that I think are valuable to the admin and programmer community to understand about some of the strengths and benefits of the IBM operating system and the Power Server platform upon which it runs. We'll have a few security officer resources available, and then question and answer I've put as a separate item, but of course we don't necessarily have to reserve that. Please feel free to send me any questions as we go through. If you do find that your question is perhaps potentially a little bit more involved, then I would offer that you can also send me an email and I can respond to you that way as well. And with that being said, I will throw up here my email address. Please note my last name is spelled T-A-T-A-M, not U-M. And so that should be able to reach me. And I'm also on Twitter. You can always ping me there as well. So, who am I? Well, my name is Robin Tatam. If you've been to any help systems webinars, especially in security over the last decade, you have probably heard my voice many times. And I am one of the subject matter experts for Common, so I speak extensively around the world about the topic of IBM security. I'm also one of the IBM champions for 2019, and that's a program that IBM started a few years ago in order to kind of acknowledge and recognize those in the IBM community that speak extensively about the benefits and the advantages of this amazing piece of technology. And so that's something that I was very honored to receive. And so again, you probably come across me. Feel free to use me as a resource. I'm not just a software person here at Help Systems. I'm also a security person focused outside in the community as well, and am a certified information security manager in that role too. So that's a little bit about me. I was a developer when I first started in my career. I wrote RPG code for over 10 years and wrote commercial applications for numerous companies around the world. And so this is kind of in my lifeblood, and which is why I absolutely love to do this session at different events. Now, of course, this is a lot of fun for everybody. It is a 2-part series. It was going to be too much to try and cram into 45 minutes. So we've set it up as a 2-part session. Feel free to take advantage of the recording of part 1 or share that. We'll do part 2 shortly, and that will hopefully round out the rest of the content here and give us a nice introduction to this topic that you can then leverage in your own position at work. All right, so here we go. It had to happen eventually. I'm going to talk about the idea of design, which I know you're all very comfortable with, and then that dirty word in the programmer's language, which is documentation. And I say that somewhat tongue-in-cheek because really, as a developer, I know that I was under a lot of pressure to get an application built and in the hands of the user to solve the business problem for which it was being developed. And as part of that, of course, building out documentation is not necessarily something that was deemed as beneficial in the heat of the moment. It's when you come back to the application, or if you have to make modifications to it or do any kind of troubleshooting, that this documentation becomes especially beneficial. I remember my early days when I was handed a green bar report that was 10,000 pages long, and they said, go fix X, Y, and Z. And it would take probably a month just to figure out where in the code a very simple modification had to be made. And so I learned very early on that by documenting, I wasn't going to do to the next generation of developers what many of the prior generation had done to me. And so I find it very important in general. In terms of security, this is now absolutely critical because there's going to be attributes on our files and our programs that, if they are not set correctly, have the potential of preventing the application from functioning correctly. So it's very important that we build this documentation in order to allow the development staff to be able to deploy modifications to the application with the correct attributes. So what does this documentation look like? Well, it's going to be something that is potentially unique to every organization, but what I've done is throw up a few bullets of the types of information that I personally like to include in design documentation, security design, especially for the auditors, the admins, and as I mentioned, the next generation of programmers. First of all, we want to include the overview of the entire security architecture. How is this application built? What is it predicated upon? Is it public permissions? Is it specific to individual group profiles, or is there adoption that is taking place here? Now, once we have that idea, we can then potentially drill down a little bit with regards to what type of profiles need to exist in order to run the application. Is there something that should be done in order to have special permissions included in the application? What I mean by that is, if your application does something like starting a print writer or firing up a subsystem, there may be special permissions that are not normally included for your end users. And so we have to consider that those programs perhaps have to be able to perform tasks that normally the calling users aren't able to do. We may want to consider documenting which files contain sensitive data. Now, that's something that a lot of organizations are currently embarking upon, is to discover that. Wouldn't it be easier if it was documented in the first place? Granted, I understand that sensitive data and the definition of what is sensitive may change over time. So perhaps what was not considered overly sensitive 10 years ago now is very critical and should be encrypted. So this is a moving target. But if there's things today that we already know is sensitive, whether it's social security number, national insurance number, credit card information, we should document which files contain that data so that we don't have to potentially search for it if some initiative comes down that requires us now perhaps to encrypt that data. We want to consider if we're using authorization lists, which is a function that I will explain throughout today and the next session, and we'll introduce that idea. But if you are using authorization lists, then let's document the names of them and what they're being used for, again, as great reference material. We want to consider and document how the data is accessed by the approved users. What are the names of the application programs? Perhaps is overkill, but what types of applications are going to be accessing the data? Is it just a native application? Is it an open source application? Are we using query? Are we pulling data through FTP or ODBC? These are all the types of notes that we want to make. Of course, we don't want unauthorized users gaining access, but at the end of the day, there has to be somebody using this application. Otherwise, what's the point of writing it? So how are those users expected to gain access to this data? Are they coming in through public permissions? Do they have private authority to the data? Or are they using adopted authority, which allows the user to elevate their privileges temporarily to perform the restricted tasks? And then if there's any special runtime attributes on the application, I mentioned adoption a couple of times and we'll talk more about that, but is there anything that should be set on those objects that if recompiled and omitted will cause issues to the application? Now, once we do that, what we're going to do, of course, is hopefully avoid the idea of have some type of failed execution by omitting something that has caused an issue. And this is really important because one of the most common things that I see today when I do security reviews for IBM customers is that there is really three areas of responsibility in building out a secure system. Number one is IBM. They created the system and wrote the OS that is running on it. They've done a really good job of building an OS that is securable. It's not necessarily pre-configured in that state. There are settings that have to be changed, but capability is there. They've done their job. Next layer of responsibility comes into the application vendors. Now, the vendors may be a third-party vendor. It may just be a programming team on staff. But the people that are developing the applications have to build an app that is supportive of those system security capabilities. We want to make sure that the OS is not capable of being locked and wide open. We also don't want to make sure that the application databases are not inviting anybody with a user ID to view and change the information. And then lastly, we also have responsibility at the ownership level, whoever owns this system. And it could be the same owner as the developers if they are in-house developers. But somebody has to own the responsibility to say, look, this data and the server on which it resides belongs to us, and it's up to us to make sure that everybody else is doing what they need to do. Now, the idea that somebody doesn't do that could then lead potentially to the idea of miscommunication and the idea that what we had as an expectation isn't necessarily fulfilled. Now, these examples, of course, are a little bit tongue-in-cheek. I just thought we'd have a little bit of entertainment before we jump too far in here, but we can see what might happen if the left hand doesn't quite know what the right hand is doing. All right, so the first thing I want to introduce to you is the concept of ownership and authority. And as I mentioned earlier, this is kind of the lion's share of what we're going to be talking about today. So, what is application ownership? Well, under the operating system, it's actually a fact that every object has to be owned by somebody. That includes objects that are created by the operating system, objects that are part of a packaged application, or just objects that even the users have created at runtime. So there is an ownership requirement that has to be satisfied somehow. Initially, the profile that creates the object is the one that is given all permissions to it. Makes sense, right? If you create something, there should be an expectation that you can do anything you want to your own objects. Now, this ownership is established when the object is first created, but it can be altered after the fact using a couple of commands. And I have them up here, change object owner and change owner. And the dependency of which command you use is really going to be based on whether we're doing native objects or whether we're doing integrated file system objects. Okay. Now, the initial ownership, as I mentioned, is claimed by the person that created the object, or depending on what is set on the user's profile, it can also be granted to the group that the user belongs to. And by group, I mean group profile. So if I'm a member of the development community in my shop and there's, say, 5 of us, and we're all part of the development group profile, it is possible when I create my application that ownership is granted to the group and not to me as an individual. But as we see, perhaps not ideal to have it owned by anybody specific to even the development community, and I'll talk about why here next. So here, what we see is a file called paynew. It lives in a library called payroll. As you can imagine, it's probably got some sensitive data in it. In this case, the owner of this particular object up in the top right is a profile called payown. A name like that might suggest it was created specifically for this purpose. And on the left-hand side, under the list of users, we see a permission for the profile payown set to an authority level of star all, which is the most permissive authority that we can give. So in other words, as the owner, this user is automatically being granted full rights to this object, meaning they can do absolutely anything and everything to it. My recommendation for developers is that when you're building an application, one of the design considerations is that we create a profile that exists for no other reason than to own all of the related application objects. Okay, this allows for good consistency, meaning that we have everything owned by one, possibly two, maybe three profiles, but for the most time, it's just going to be a single profile. It makes it very simple then if we have to migrate this application to another server, because in the normal scheme of things, what we have to do is, first of all, restore the profile that owns the application, restore the application, and then restore the permissions, which establishes the link between the two. And if you have your application that perhaps consists of, say, 100 objects, and it's owned by 5 different programmers, or maybe 10 or 15 that have worked at your shop over time, it makes it very complicated then to actually get those profiles restored back. But everything is owned by one. All you have to do is restore the one profile. It just makes life a whole lot easier. Okay. Now, my general recommendation for people is not to make your application owned by using an IBM supplied profile. Okay, so the Q programmer, the QSecOffer, the QSysOpper that we all know exists on every system probably should not be used as the ownership of that application. There's a very simple reason for that, is that there are permissions granted to IBM profiles that you may not be expecting. And if you use any type of adoption or anything like that in your application, you may be adopting permissions beyond what you are expecting. So not a big fan unless there is a specific requirement that an application have those types of privileges. Rather, I would have you copy an IBM supplied profile, give it its own name, and then leverage that, because then it's just similar to QSecOffer. It's not necessarily the full-blown original profile. All right. Now, the profile that owns the application typically does not need any special authority. That's a parameter on every user profile. Their special authorities are considered admin privileges. Most of the time, the application shouldn't carry any of those types of authorities unless you're writing functions that specifically require it. And how do you know that? Well, you'll find out pretty quickly during your testing. And of course, you all test your applications, right? Now, really what I suggest is, if you know inside your application, and it's typically going to be more of a CL type code function, if you're performing anything like starting a print writer, starting or stopping a subsystem, things that are more system oriented, there is possibility that the application may need privileges. And there's two choices there, either for the calling user to have that privilege, which is typically not recommended for just simple end users, or if we're going to use adoption, then the owning profile may need to have that privilege so that we can introduce it into the security checks. For right now, let's assume there is no special authority requirement. And under that, what I've done here is granted or given you visibility into how I might create an ownership profile. So what I've done is leverage, of course, the create user profile command. I have indicated the name of the profile here, which is going to be payown. I've said that there's no password associated with this account. And what does that mean? It means that the profile cannot be used for sign-in. It doesn't mean you don't have to have a password. It means there is no password, which means this is not a profile eligible for connection. And that's important because, as I said, the profile ownership requirement is a base OS requirement. We are not doing this because we want to. We're doing it because we know it has to be done. So let's just set up a dummy profile that is consistent across all of our application objects. Okay. Now, special authorities have been granted here is *none. We don't want any all object. We don't want any job control in this particular instance. So we're making sure that this profile carries none of that. Because we're not actually going to sign on with this profile at any time, the initial program is set to none, and the initial menu is set to sign off, and the limit capabilities is set to yes, meaning that nobody can override it on the sign-on screen, but the initial menu will cause the user to be bounced back off if they do actually assign a password to this. So some of this is overkill, double duty, if you will, but the fact that we have set the password and the initial menu and everything to be consistent with a profile that is a service account, if somebody changes one of those elements, the next layer should catch it and sign the user back off. I've got a recommendation here. If you have some type of application builder, that could be a homegrown program that just goes through and compiles all the programs, or if you use even a commercial lifecycle manager or change control tool, we can ensure that when objects are created, be it the profile or the application objects themselves, that during the promotion of those objects into production, we can ensure that the ownership is assigned and any public and private permissions that are necessary are granted as well. So that helps take some of the human element out of this and helps resist the idea that something may not be set correctly. It's worth noting that it is possible to override or modify the permission that was granted to the owner to their own objects in a way that would prevent a user from accessing their own information. So as a programmer, perhaps I create a file. It can be changed so that I don't have the ability to see the data in that file or change it. But what we've got to remember, however, is that as the owner of that object, I have certain inalienable rights, meaning that I have, as one of my just God-given permissions, the ability to set the authorities for other users. Now that includes me. So I can go into a file that I've been restricted from and grant myself access back. So this is not typically something we do. We don't expect a programmer to own an object and then be excluded from it, but just know that while it does appear to be possible to do that, it's really nothing more than a mere stumbling block, and most users would have the ability to change or override that on their own objects anyway. We have to understand during application runtime, going to be the potentially times when a user who is running the application is actually going to be creating objects on the fly. They may be perhaps creating a work file that is used during a posting process so that an undo function can be established. Inside those CLs, as a programmer, what we tend to do traditionally is just create that work file, create the object. Maybe it's a data area, and we use a create command in order to do that. And then we move into actually populating the file or calling the program. What we have to do now, however, is consider that not only do we have to create the object, as in step one, but we now have to establish the correct object ownership in step two, and then grant the permissions necessary to that object in step three. Now, this assumes that the object is somewhat permanent. If it is a qtemp type object that is only there for this user and it will be deleted at the end, maybe you don't have to worry about this. But if there is the possibility that you're creating a file that will then be used by a different user to run the next step in the process, it's very important that we take step two and step three and add it into what we've already been doing for years in step one. All right, so here's a concept that is probably very familiar with you by name, and that's public authority. Although what I do find when I do present to people and I ask the attendees to give me their definition of what is public authority, you would be amazed at how many different definitions I actually hear given to me. So I'm going to give you some clarity here, hopefully, and explain exactly what my perception of public authority is. Now, public authority is not really an authority setting per se. What we first have to understand is that it's an authority setting that is granted to the public. So the most important part of this concept is the word public and understanding who is part of this, this mysterious group. Well, really the way that it works is that the operating system has an authority algorithm that is used when a user says, I wish to access this object. The first item that gets checked is whether the user has what's called all object special authority. As its name suggests, all objects means you can get your hands on any object you want. Assuming that that is not the case, then the operating system will start determining if there is any private permissions, meaning that there is something explicit to that user or any group profiles they may belong to. Robin, you can look at this. Robin, you cannot look at that. That is a private permission because it's specific to me. If there is no mention of my name, and no mention of a group that I may or may not belong to, then there is a third and catch-all definition for those permissions. And the people that fall down to that level are considered public. Okay, so they are in fact users who have credentials to the machine, but that don't have any explicit permission saying what they can or cannot do. All right, so that's really it. Now, when we create an object, the public authority tends to be assigned based on the create command that is used. That's especially true for native objects, physical files, data areas, RPG or COBOL programs. The public authority is going to be garnered from the create command that is relevant to that object. If, however, it's an IFS-based object, or what we call a stream file, public authority is typically inherited from the parent directory in which that object is created. Okay. This is what it kind of looks like for native objects. So when an object is initially created, there is a one-time resolution that is done by the operating system to determine what the public authority setting should be. I mentioned the create command. So there's actually an attribute called authority on the create command. You can prompt up a create RPG program to see this. And the default definition for that public permission is a special deferral called library create authority, meaning that the create command doesn't want to make the decision. It says, instead, go look at the library in where this object is being created, and on the attributes of that library, there is a parameter that says what the permission should be for any public user inside that library. Now, if we then defer to that, what we discover is the library definition by default has a parameter that indicates it also is unwilling to make that decision. There is a deferral again that says go to a system value to determine what the public permission should be to that object. And if we follow that to its final resting place, what we find is a system value by the name of QCreateAuthority, and inside that system value is an authority setting that will be granted to that object. Okay, so it's a three-layer deferral that's happening here. My note down here is important. This is not a dynamic deferral, meaning that if I create an object and then subsequently go change the system value for QCreateAuthority, it is not going to have any influence or impact on that existing object. So this is only done, this daisy chain of events here is only performed when the object is initially created, and then it's set. You can still go override it at the object level, but this inheritance, this value deferral, is only going to happen during the initial connection. Okay. Now, for me, I take up issue with this QCreateAuthority system value. A few reasons why that is. Conceptually, nothing wrong here. This public authority idea is actually quite flexible. It simply means that it's possible to set a default permission, which is fairly unique to IBM. Most operating systems work on the premise that if you don't have permission to something, you are not allowed to use it. Here, we say if you don't have a specific permission to something, this is what you can do. This is the base authority. Really, the problem stems from the fact that IBM ships this system with the OS pre-configured in a state that this system value is set at start change. Most of us leave it at that value, which results in any user with a user ID and password often being able to see, modify, and even delete data in a file. Oh, and they can also run applications. Well, let's think about it. What more would a user possibly need to do than see, change, and delete data and run programs? And that's the default permission. So if we're one of those programmers that has built our application without paying any attention to the public or private authorities on our objects, then by default, any user who can get on my system, or any user who is pretending to be somebody who should be on my system, is able to do anything they want. Now, bear in mind, a corrupted system requires change permission to the database. And a breached system only requires use permission to the database, right? So when we look now in terms of data corruption, malware, or even just a simple data breach, anything other than exclude potentially would allow that. So that's why we talk about this in general, is the idea that by default, IBMI says do whatever you want, and it's up to us to turn that setting off. Now, we've got this 3 layers of deferral. What I suggest is that you only go to the second level. I understand that there's definitely benefits in having a command defer perhaps to the library settings to determine what the public permissions would be. What we're doing there is allowing a generic value to be inherited across all of your application objects. For most of us, we're not just running one application on this server. We have many different applications. And so what I struggle with is the idea that we have one global system value setting that knows across all of those applications what the best public permission should be. So what I'd rather do is cap that deferral at the library level, knowing that each application lives in 1, maybe 2 or 3 libraries, but it still gives me the benefit of this generic setting at the create level, but it doesn't defer back to just one single all-powerful being. It's done more at an application level, right? So we get the benefit without going too far and paying the penalty. Every object has a public permission associated with it. Again, just as a reminder, this is the amount of authority that is being granted to any user that is not known by name. Here's an example of an object. This is, again, the pay new file that is set to public exclude, probably appropriate for something like payroll data. If you're not part of the HR department, you probably shouldn't be able to see, download, copy, or certainly change this type of data. So public exclude is a very consistent and appropriate type of authority. And there are some shortcuts that assist us with establishing the type of permissions a user should have. It's important to understand that in order to access any object, a user has to have the necessary and relevant permission. The authority algorithm actually determines from most granular to least granular whether the user has the necessary authority. So everything is first checked based on the name of the individual. So as a user profile named Robin on my server that belongs to the developer group, maybe also the admin group and the power user group, it's first going to look for anything that's explicit to me. So even if the power user group is allowed to see this data, maybe I'm a problem user, or maybe I'm in a position that I should not have access to this, and so I need to have the ability to set exceptions. And so Robin, even though the group's allowed to do it, Robin should not be allowed. And so by checking authority first at the individual user level, IBMI supports that capability. If there's no reference to my profile at all, and I don't mean there's just insufficient permission, there's no reference to me at all, then the operating system will say, okay, now I'm going to check to see if you belong to a group profile. And if you do, I'm going to determine how much permission you're being given based on the group's authority to the object. If I belong to multiple groups, then that authority is consolidated. And I'll paint a picture for you of what that means in a little bit. If there's no group profile in play, or there is no group profile defined on this particular object, then I just drop down to this final layer that is public. So that's the default permission that would be granted to any user that is not indicated based on their name or any group profile membership that exists. Now, this authority algorithm is something that is published by IBM. You can find it in the security reference manual, and it does get somewhat complicated, but if we take out a lot of the noise and we just bring it down to its simplest terms, it's basically going to be as I just previously described. I did extract that information out of the security reference manual. I put some colors on it and made it a little bit more graphical and put it into a one-page chart. If you'd like a copy of this, as it shows on the screen here, feel free to send me an email and I will be happy to send you a PDF version of this one-page document that has this information listed on here. But this is just a very simple way of representing how IBMI gets its determination as to whether a user should have access to an object or not. The most important takeaway for me is that the operating system is extremely consistent. There is none of this, well, it worked yesterday, but it doesn't work today, or I was permitted yesterday, but I'm not permitted today. Just like anything that is IT oriented, if something changes in its result, it means one of the input variables changed. So this allows you to follow the flow of how the operating system makes its decisions whether a user is granted access or denied access. And this can be helpful in troubleshooting. Of course, if you're a version 7.3 or later, we also have what's called authority collection, where the operating system will inform us why a user potentially was denied permission, or likewise, why they were granted permission. Okay, but this flowchart is a nice visual way of seeing what that is. Okay. Now, in return for sending you that, what I'm going to do here, there's a couple of polls I'm going to do today. And what I'm interested in, just as feedback for you guys, is what is your responsibility at the organization? So are you coming to me today as somebody who is a developer on your team, or perhaps somebody who is an admin, or if you fall into some other role? Now, you can answer multiple because I know it's IBMI and we tend to wear multiple hats, but just give me a little bit of feedback about what your responsibilities are. Just give you a moment to do that. Should only take a second here. And it looks like most of you are sysadmins or developers. 79% are programmers and developers, 50% also fulfilling a sysadmin role. So some double duty there by the sounds of it. So that's fantastic. Thank you very much for that. I'll just give you an extra second here and then I will close that out and we'll keep on chugging away. All right, perfect. Now, under the operating system, we have what we call authority templates, okay? And the idea here is that we're trying to simplify the security administrator's life as much as we possibly can. So there's 4 templates. Starting from the bottom, working up, they're working from the least amount of permissions, exclude, of course, permission to do nothing, up to a permission of star all. Now, why do we need a permission that says we can do nothing? That seems a little strange. Well, we have to do it because there is this concept of public that says if you're not explicitly excluded, you still potentially could get a default permission. So that's why that's necessary. Now, the idea behind these templates is that it simplifies what in essence is a little bit more complicated under the covers. So there's actually a number of different permissions that can be established on each and every object. I don't know about you, but this is probably not something that I want to manipulate manually. And so IBM determined that there really were, outside of exclude, only 3 types of roles that perhaps were necessary. And so they created that as a template definition, making our life very easy when our objects are pretty straightforward. That's not to say that you can't override those into a user-defined permission, in which case you can add and detract from any individual column in any combination that you want. But for the most part, the templates seem to work quite well. Now, as I mentioned, there are 4 different templates. Exclude means that you can't touch the object. Of course, if the user has all object, that is the first thing that's evaluated. So it's important to understand that it takes precedence over any private or public permissions. When we up the ante a little bit and we go to use, now we have the ability to touch the object. If it contains data, we can see the data. If it's an application, we can invoke it. Okay, so that is the minimal amount of authority we need in order to do something. Then we go up to change. The difference now is that we have the ability not only to see the contents in the object, we also have the ability to manipulate them. And then lastly, we have all, which means you can do everything. Not only can we now manipulate the data in the same way we can with change, but we can also manipulate the container, the object that that data is in. So if it's a physical file, not only can I delete the data, but I can also delete the file itself. Arguably, if I've deleted all the data out of a file, I've done the damage already. So in the case of change or all, to me, not a huge difference. I've already done the problem if I've flushed the object of its information. The fact that I can't delete the container, probably not the biggest, most important issue at that point. Now, there's really very few reasons why we would need to grant all permissions to an object. So don't give that away like it's going out of style. But if your alternative is giving the user all object special authority, which is something frequently done to programmers, it is important to understand this is much more controllable. Now, as a developer, or as most of you are developers, I know that there is a consensus that we have to have all object in order to support an application. But what you've got to understand is that not only does that give you access to every object in the application, which may be permissible, it also gives you all permission to every object on the server, including the OS. And there's single commands that you can delete the operating system with, which is a permission that should be given to no one. Okay, so as a developer, one of the things we want to understand is, do you need access to all the objects in the application, which can be accomplished through this star all setting, or do you need access to all application objects, all user objects, and all operating system objects as well? In which case, you're probably going to grant all object, but that is much more of a smaller community, in my opinion, than the all permission at the object level. My hot tip down here is, if you can use the templates, do that wherever possible. It just simplifies your life rather than assigning individual permissions on all these objects. That's a lot of work. So it's not something I personally would do manually. If I didn't have some automation in place to do that on my behalf, I don't think I'd do it. Now, under all of these different permissions, the first four of them from a native object are treated and what are called as object authorities. And that's because they control the amount of function the user has to the object itself. Now, this is mainly relevant in clarification for things like files, right? A file is an object that has data within it, but a program isn't. So if the program is an object that you wish to touch, then not only can you run it, but here you can also rename it, delete it, and other things. So we're talking about functions that are available at the object level. I define these here not because I'm going to go through them in the interest of time, but just so you have reference to them. If you have a copy of this presentation, you at least have something to refer back to that explains what the different authorities control. We also have what's called data authorities. These are more self-explanatory, I think, when we talk in terms of a physical file. The ability to read the data, change the data, delete the data makes sense. We also have an execute permission that is more relevant to a program, the ability to call that program. But these permissions are actually on every single object. So even though it's an RPG program, for example, there is read, add, update, and delete, then they're really not as relevant as they would be on a physical file. Again, this table discusses that, but I think this is more self-explanatory. We're more used to this as a concept because it makes sense to us, I think, that we can read and update data in a file. Now, I mentioned if a user belongs to multiple group profiles that there is some consolidation, because one of the most common questions I get is, well, what if I belong to two groups? One is allowed and one is excluded. Who takes precedence? And it really isn't a matter of taking precedence. When we look at group 1 and group 2 here, we'll see that group 1 has all permissions to a particular object, which means that it conveys out X's across all of the individual authorities. And the second group is excluded, which means it has none of those X's. So when we apply an exclusive or relationship, what we see as the result is that the user effectively has all permission. Let's say, for example, that group one did not have read, add, update, and delete, in which case there would be no X's in the result boxes for those columns either. Okay, so it's really a combination of all groups. You can be a member of up to 16 groups at any time, although honestly, if you're a member of maybe 4 or 5 groups, I wouldn't go too much further than that. Okay, otherwise you're getting a little bit too granular in the roles that you're defining for your users. All right, so that's how multiple groups come into play. Another concept that's very important to understand and can be your best friend, quite honestly, is the fact that the operating system performs 2 primary passes before it grants a user access to an object. The first level is at the library level. So I'm sure most of you understand the concept. A library is a container that houses objects. You have to have permission to the library before you have any chance of accessing the objects inside. So the first thing we're able to do is determine whether the user has permission to that particular library. As the fortress wall around the objects, you just have to have use permission to get in the door. That is not going to suggest that you can only read the data in that library. No, the 2 authority checks are really kind of separate. So once you're inside the library, it's almost like a reboot of the authority check. The fact that your use permission got you in there now really has very little bearing on what you can do to the objects inside. If you are indeed able to access the library, the operating system will perform a secondary evaluation now at the individual object level to determine if what you're trying to do to that file or program is appropriate. What this means is that by creating an application that is secured at the library level, we can very quickly and easily exclude the non-authorized users from accessing any of the objects without paying too much attention at the object level itself. Why is this important? Well, if you count up the number of objects on your system, and you compare it to the number of libraries on your system, you will quickly discover that the number of libraries is very minimal. So if we are struggling with the amount of work that we feel object level security perhaps entails, by securing at the library level initially, we're able to reduce the amount of work to something that often is quite manageable. Once the user gets into the library, you still may want to have different settings on the objects, but if you are trying to deploy this or at least engage in the idea of object level security without being too overwhelmed by the scope of the effort, securing at the library level initially is just a fantastic way to dip your toe in the water and to add a lot of benefit in the process. So here we have some ideas. Now I'm going to kind of wrap up here in just a minute. We're going to finish up again, as I mentioned, in part 2, but I want to establish the idea that it is possible to build an environment that is fully compliant with object level security in a very quick and easy manner. Okay. Now, one thing for me, I tend to segregate my programs from what I call my data objects. A data object is something like a file, a data queue, a data area. It contains information that's going to be there one moment and perhaps not there the next, or it's modified the next, versus a program that is compiled and sits there potentially indefinitely. With my program segregated from my data objects, what I'm able to do is set appropriate settings based on the type of object. So for my programs, as an example, I'll drop those in a library and I'll allow users the ability to invoke them by granting use permission to the authorized users. With my fluid or dynamic objects, what I'm going to do is put them in a separate library and then potentially grant use or change permission, again, only to the authorized users. So the idea here is that we start off ideally with no permissions, and that's the public setting, and then we gradually open the door to those users that have a defined, clearly defined business requirement to be there, okay? So down on my hot tip, if you're using adopted to swap authority, which we'll talk more about, It's even possible to set public authority to exclude, and I would offer that that's the ideal scenario. We want to follow what we call a deny by default model, which means you have no permission until I grant you permission. And by setting public authority to exclude, we are following that type of concept. All right, so let's take another quick poll here. Let's see. I'm curious about the types of initiatives that you have or the struggles that you have pertaining to security. The nice thing is that a lot of you are developers. You've got 79% of you that have reported that you are developers. So in this case, is security even on your radar? Is it being granted to you because of some type of regulatory mandate? Do you have reporting requirements? Do you need to justify to management somehow that there's an effort needed here? One of the things that we know from the state of IBM I security is that most IBM I systems are completely misconfigured for security. But even when we bring to the attention of management that that's the case, we struggle with the idea that it's going to cost money or require resources in order to change that. Of course, hey, we're inside the wall. Well, we all know firewalls are not impermeable, and so what we have to recognize is that if a user is either inside the firewall to begin with, or if they have penetrated the firewall somehow, what can they do when they get there? And of course, with IBM I, we want to make sure that the database is secure, and the reality is we've seen that default permission is wide open. So looks like about a half of you are working on staying in compliance with security mandates. Regulations, of course, the biggest catalyst of change in this area. About a third of you with security reporting. 50% of you, actually 48, just changed in automation. So making sure that this isn't a full-time job seems to be something that you want to make sure you avoid. And then management justification, about 44% dealing with that. So if that's the case, certainly that's an area that potentially we can help with. Perfect. All right. Well, thank you for answering those. All right, I'm just going to cover one more slide with you for now, and that is one that you will probably have seen or will see, is the idea that if you use object level security, at some point you will over-secure an object, okay? And that's a reality of things. Starting in 7.3, I mentioned authority collection can help limit this possibility quite dramatically. Actually, I'm a big fan of that capability in the OS. But there is a reality that most likely you will have a user that reports that they were unable to access an object. Of course, assuming you are auditing, an AF entry should be logged into the IBM Security Audit Journal. That can help you diagnose what's going on here. But this is certainly the first line of defense. And then authority collection, of course, is a more modern way of perhaps either avoiding this in the first place or diagnosing what the problem was. Authority collection has to be running at the time that the authority rejection occurs in order to be beneficial, and that's not always the case. So sometimes we get a message, we can't quite figure out what's going on, so we can turn on authority collection, ask the user perform the task again, which presumably will fail again, and then now we have the information necessary to fully diagnose why the rejection occurred. It tells us how much authority the user had, where they got that authority from, whether it was successful or failed, and how much authority they actually needed to the object. That's the magic there, because it helps us map out the necessary permissions. All right, guys, what I'm going to do is give you one last poll here. This is a simple one. One of the functions that I perform here with my team is that we perform security scans of IBM I servers. We do that at no cost. If you're interested in having one of those run, you're certainly welcome to take advantage of that here. We can get you more information if you're interested, but you're not quite sure and you don't want to commit. Then we can get you more information about that as well. If it's been at least a year, if you've done one before, let's do another one. We always are interested in keeping those up to date. So if you want to take advantage of that, you're welcome to do so. If you're not the appropriate contact to make that decision, put down maybe. and we'll be happy to reach out to you. You can pass us along to somebody else. Like I said, no cost and no obligation to do that. So it's a very unique thing for you to take advantage of. All right. So as I mentioned, this is part one of part two, and we will send you information about connecting to part two. Hopefully part one has whet your appetite and given you some good information to get started on this. If you do have questions, please feel free to use the question panel to pass those along to me, and we'll see what we've got going on there. And I'm going to look right now and see. So June, if you're still online here, mentions that you have a user profile and a group profile in which supersedes. I think I answered that in the content, perhaps a little bit further down. In other words, the individual user takes precedence over the group. Okay. In fact, the groups only come into play if there is no reference to the user. So definitely a clearly defined priority there. Joyce, you asked, if you have use permissions on a library, what damage can you do? Oh, that's a great question. So take the scenario where I have use permission to the library, but I have delete permission to the objects inside the library. Perhaps I have all permission to the objects. I can delete those objects. And I can do that because use permission got me through the door, and then anything I do to the objects is controlled by the object settings. About the only thing I cannot do with use permission on the library is put new objects into it. But let's face it, are you more concerned with somebody creating something new, or are you concerned with somebody doing damage to something that exists already? And for most of us, the answer is more concerned about the existing objects. So that use permission is still quite powerful, and don't be lulled into thinking it's read-only permission that gets pushed down to the objects inside. Okay. Carlos, noting that you've got a lot of service accounts that have all object that you still need to wrangle with. Okay, so if it's a service account, to me, making sure that a service account is not used for sign-on is kind of like the ownership profile. Setting it up so that it's star sign-off and has no command line permission. That will help reduce the risk associated with a service account having all object. Where the all object becomes very dangerous is if somebody can make a connection and interact with the server as that service account. If they're not able to do that, then it's kind of like having a Ferrari but not having the keys. There's potential, and I'm not saying it can't be hotwired, but the reality is the average user is not going to be able to start it, okay? All right, that's all the questions I have for now. If you are a little shy and you'd rather ask offline, please feel free to email me your question. I'll be happy to answer that. Or if you want to listen through part two and then perhaps consolidate your questions, we can do that as well. But for right now, I'm going to say thank you. I appreciate you joining. I look forward to you coming back for part two. We'll make sure you get a link to the recording as well as the information you need in order to connect to part two, and I'll look forward to talking to you soon. Thanks, everybody. Have a great remainder of your day.